For part 1, we need to compute a common friend with MapReduce. And for the mapper task, I create a string tokenizer which will perform split on new lines. So for each line of the input file, I will split the line with this substring. By doing so, this will yield left part, which is the username, and right part, which is a string of friend list. I then split the friend list string with the space. This gives me an array of friends. Then I look through each of the friends. I construct a array for the input key array. I then fill the array with the username from the left I get here and the one of the friend in the friend list. Before I construct this key, I also want to sort this array because I want to make sure the comparison between user A and B is the same as user B and A. So I always sort the key before I construct the actual key to do the emit. Once I have this piece down, and then I do the emit with the arrays, and the value will be the list of friend. For the mapper phase, since we are comparison between two peoples, so we will always have two items in the value for each key. So I want to store them into separate array. That's what I'm doing here. And once I got that finished, I create an empty array list to hold the common friend. I then use a nest for loop to compare and find the common friend between the two arrays. Then once I found a match, I push the friend to the array list I construct. After that, I use a string builder to build a string as the value of the value in a key value pair. Then I do the emit with this key and the string builder I create, which then I use a toString to give me the string value, and use a trim to remove any new line or space at the end. The main function is more or less the same as we're using in the word count, nothing special there. Now let's go ahead and run the code for the part 1s. To see the input of part 1s, which is the friends.txt files, here's the input. Then I have a jar. I'm using Maven to write my project, so I build a jar with Mavens. Then I can go ahead run this task to produce the output. So it will be Hadoop jar, the name of the jar, and the class name, input file, which is the path on HDFS, and output directories, and also the path in HDFS. So now you will submit a task to the Yarn, and Yarn will handle the mapper and reducer task and allocate a resource for each task. Seems like a mapper finished. Now just wait for the reducer. As the task finished, now we can check the output of the common friend, and according to the output, A and B have common friend for CD, A and C have common friend for BD, etc. And that's how I did it for the first part. For the second part of the lab 1, I need to compute the average response time from several log files. In order to do that, I create a map which will also use a string tokenizer. And for each line of the file, I perform split based on these characters. By doing so, I can have the turn on the left and the actual response time on the right. Then I do the emit. That's the mapper task. And to make the task more efficient, I decide to use a combiner as well. So for combiner, I want to get the average response time from each smaller task from the mapper. So to do that, I create a count variable to holding the number of count and sum to holding the current sum value of this smaller task. Then I loop through the values, and for each of the value in values, I increase the counters and add up the value to the sums. Once that got finished, I have the sum and the count. I can then compute the average response time. With this value, I do the emit. For the emit, I still use the same key, but for the value, I use slightly different. I want to use the average response time, comma, count as the actual value. By doing so, I will still be able to get the current task sum's value in the later reduced phase. So now let's go to the reduced task. For reduced task, I have a couple different variables. First one is total count. Because the count in the combiner task or combiner phase is not the actual total count. So I'm going to use the total count to add up the count from the combiner task. As well for the sums, because the sum from the combiner task is only the sum for the combiner phase, it's not the overall. So I will need a different sum in the reduced phase. And this sum we're going to add up all of the value from the combiner as well. So I look through each of the value in values. Then I split the value, which is the key value pair, with comma. By doing so, I can get the average response time and count from the combiner task. By doing so, I can then use average and count to count the sum from the combiner task and add this value to the current max sums. Then I also increase the counter by adding the value of count into the total counter. After this for loop, I have the actual max sum and max count. Then I can compute the final average response time. Once that got finished, I do the emit with the same key but the new values. In this case, the value is actual average response time for each turn. And I did make one line change in the main task because I don't want to use the reduced task for combiner, which by default that's the case. I want to use a separate combiner task. So I call job set combine class with the combine class I wrote here. Now let's go ahead and run the code. So I create a directory called log, which is under the user caldera/logs. They have two files. Under the log, that's all I'm going to read. So here's the content of the first log file. Here's the content of the second log files. And I can also see both content with the star signs. So the task will go ahead and release input file, and that's the turn and the response time. It will calculate for the output, it will calculate the turn and the final average response times. Now let's go ahead and do that. So here's the command I'm going to run. Hadoop jar count, that's the jar name I create with the Maven, and that's the class names. And in here, instead of specifying the particular input file, I'm using the input path. So we will read over the file under this directory, and here will be the output path. As you can see, total input path to process is 2 because we have 2 files. So when they store on HDFS, they store as data block. Now the mapper phase finish, you will run a reducer. As the reducer finish as well, we can go ahead check the output. So from the output, the turn have average response time of 3.213333, and turn B have average response time 3.33333, and C have average response time 4.975. Thank you.